Hello everyone. In this video, we are going to look at a previous question paper and we're going to focus on the chapter of electric circuits. Without any waste of time, let's get right to it. The first question that we have, it says, in the circuit diagram below, the reading on voltmeter 1 is 12 volts and the reading on ammeter 1 is 2 amps. So if you look at the diagram that we have, we see now the voltmeter 1 is the total voltmeter of the circuit since it is placed on the battery. And therefore this current, which is 2 amps on ammeter 1, it is going to be the total current because it's going to be the current that comes out from the battery, which is going to flow around the circuit. So we know that if the current splits, therefore these two resistors are going to be in parallel. But when the current meet again together here, it is going to be the total current. So therefore, the resistance of 4 ohms is going to be in series. With that analysis being done, we can start now to answer the questions. So the first question that we have, they say, calculate the total resistance of the circuit. So we can use what? The Ohm's law to calculate the total resistance. So Ohm's law says to calculate the total resistance, you need the total voltage and the total current, and you will get the total resistance. So we have the total voltage, which is 12 volts, and we have the total current, which is 2 amps. So we can substitute now. We have 12 volts here, and the current is 2 amps, so we can get the total resistance. So now we can divide both sides by 2, and then the total resistance will be the same thing as 12 divided by 2, which is 6 ohms. So now if we did not have this total current here, we would still be able to calculate the total resistance, because the total resistance is the same as the resistance of series plus the resistance of parallel. So we have already identified that the resistance that is in series is 4 ohms and these two are in parallel. So we need to add all the resistance in series and all the resistance in parallel to get the total resistance. So the resistance in series is equal to 4 ohms. So to calculate the resistance in parallel, we use the equation for resistance in parallel. So it's 1 over R parallel equal 1 over R1, 1 over R2. So we're going to substitute now our resistance that are in parallel, which is 6 ohms, 1 over 6 plus 1 over 3. So when we add 1 over 6 plus 1 over 3, we get 1 over 2. But now we are not looking for 1 over R parallel, so we must do the reciprocal. So the R parallel will be the same thing as 2 over 1, which is the same thing as 2 ohms. So we have the R parallel as 2 ohms and the R series as 4 ohms. So now to calculate the total resistance, we can just add them. So the total resistance will just be the same thing as R series is 4 and R parallel is 2. So when we add this together, we end up having 6 ohms. So it's the same answer that we got when we use Ohm's law. So the next problem, which is 11.1.2, it says that we must calculate the reading on voltmeter 2. So voltmeter 2 is this one here. So we know that voltmeter 2 is placed on 4 ohms resistance, and we also know the current that will pass there is the total current, and the total current is 2 amps. So we can calculate the voltmeter 2. So we're going to say the voltmeter 2 is all the information that we have in that resistor 4. So we're going to say now the current that will pass through 4 ohms and the resistance of 4 ohms. So we know that the voltmeter 2 is going to be the same as what? The current that passes through 4 ohms is total current. So it's going to be 2 amps multiplied by the resistance of that resistor, which is 4 ohms. So now to get the voltage, we're going to say 2 multiplied by 4, which is going to give us 8 volts. So the voltage of V2 is 8 volts. So but now if we have the voltage of that as 8 volts, what will be the voltage of the parallel? Because now the voltage of the parallel is the same thing as one parallel resistance. So because we know that we have the voltage of the battery to be 12 volts, therefore the sum of the voltage of V2 plus the parallel must give us 12. So if this V2 is 8, therefore this one, it has to be 4 volts, so that when we add them together, we get 12 volts. So the question that comes, which is 11.1.3, they say we must calculate the current in ammeter 2. So ammeter 2 is this one here. So with that illustration that I have just made, we know that it's going to be 4 volts in that resistance and 4 volts in this resistance. Since the voltage in parallel is the same and it's just one voltage. So to calculate this current, we can use the resistor of 6 and the voltmeter of 4. So now we can say now, okay, the voltmeter in 6 ohms is equal to the current, which is A2 multiplied by the resistance in what? In that 6 ohms. So to calculate this current, which is A2, we can substitute the total voltage on that resistance. So on that resistance, the voltage is 4, and therefore we can get this A2 because the resistance is 6 ohms. So you're going to divide both sides by 6 so that we get the current in ammeter 2. So 4 divided by 6 is the same thing as 2 over 3 amps. So the question that follows, it says what? It says calculate the amount of charge that flows through ammeter 1 in 120 seconds. So this is ammeter 1 here. We know that ammeter 1 has 2 amps. So if they want the amount of charges that flows through that ammeter, we know the current is how fast the charge is flowing. So it's given by this following equation. So we are going to substitute the ammeter of that ammeter 1 is 2 amps, and therefore we say now we're looking for the charge and the time is 120 seconds. So this is all over 1. So when we cross multiply, the charge will be the same thing as 2 multiplied by 120, which is 240 coulombs. So that is how we will determine the charge. So now, as we move on to the next question, which is 11.2, they say, how will the reading on ammeter 1 be affected if 6 ohm resistor is removed from the circuit? So let us try to understand what they're asking here. So they're saying that if we remove resistor 6, what will happen to the current? Will it increase or decrease? So now remember, this current is related to the Ohm's law. We know that Ohm's law says the potential difference is equal to that total current and the total resistance. So now if we remove this resistance here, we are changing the total resistance. So therefore the current will have to change since the voltage is the same. But now how will it be affected? So by removing this resistance that is in parallel, we are actually increasing the total resistance. Because now if these things are in parallel, to calculate their total resistance, we were going to get 2 amps as we have calculated, 2 ohms. But now once we remove it, we are going to be left with these 3 ohms. Do you see now 3 ohms is bigger than 2 ohms of the parallel resistance? So therefore, the total resistance is going to increase. So now if you increase the total resistance and then you kept the voltage to be the same, you must decrease the total current so that you have the same voltage. So this question of 11.2, the current is going to decrease since by removing this resistor of 6, we are increasing the total resistance. So the current will decrease. So the next question that comes, it says, explain the answer to question 11.2 without any calculations. So now I have already explained the answer. We said what? Okay, let me just write that down. We said now, if we remove resistor in parallel, we are actually increasing the total resistance. So now, if we increase the total resistance and the voltage is kept constant, if we increase total resistance and the total voltage is kept constant, the total current will decrease. The total current will decrease so that Ohm's law is not violated. We don't violate. Yeah, you will write the right spelling, Ohm's law. Okay, so that is how we'll answer this question paper, and thank you.